All right, so today I'm going to do a test review over the Module 1 test, just a few problems that I just want to explain for the benefit of everybody. They may or may not have been through the recordings. I noticed that some of the problems have changed, so just to make sure that these problems are covered. When you're taking the exam, here's some things that you will need in this formula sheet section. You're going to need the all exam formula sheet. And I'm also going to bring up the unit circle function values chart. Okay. And you're also going to need the reference angle chart. Either this reference angle chart or the one that was provided by Mr. Charles Whiteman from last year. Okay. But I'm actually not going to do any problems that are based on the unit circle. That was kind of in a couple of those videos, but you will see reference angle, or you will be asked to find reference angles on the test. All right, so with that being said, I'm just going to bring up it's like 6 problems or so that I want to go through, and you will have to be able to convert to radian to degrees and also from degrees to radians. So just to make sure everybody is just on board with this, in order to convert from a radian to a degree measure, you want to multiply by 180 degrees divided by pi. Right, so if we were asked to convert 3 pi over 4 to a radian measure, if we were asked to convert 3 pi over 4 radians to a degree measure, we would simply multiply 3 pi over 4 by 180 degrees divided by pi. Once we multiply, the pi's are going to cancel. And I can reduce 4 and 180. Both of those are divisible by 4. 4 divided by 4 is 1. 180 divided by 4 is 45. Now if I multiply my numerators, 3 times 45 degrees is 135 degrees. And then for my denominators, 1 times that understood 1 is 1. All right, so we have 3 pi over 4 is 135 degrees. You can also find this value on the unit circle. Right, the unit circle, it's on a document by itself, but it's also on the last page of the all exam formula sheet, so we can see that there's a conversion here. 3 pi over 4 is 135 degrees. You can also find that conversion on the function value sheet. Okay, 135 degrees is 3 pi over 4 radians. All right, next we're asked to convert degrees to radians. So we're asked to convert negative 40 degrees to radians. So whenever you're converting from degrees to radians, you're going to multiply by pi divided by 180 degrees. All right, so I would also look at the unit circle and the function values chart, but 40 degrees, right? We have 30 and 45. We don't have 40, right? So we're going to convert it by multiplying by pi over 180 degrees. So I'm going to multiply negative 40 times pi divided by 180 degrees. A negative times a positive is a negative. we can divide both 40 and 180 by 20. So I'm going to cross reduce. So 40 divided by 20 is 2. And 180 degrees divided by 20 is 9. And also the degree cancels. So we have 2 pi over 9. All right, so 40 degrees is 2 pi over 9 radians. All right, next we're asked to find the arc of a circle, and it says that the radius is 14 inches and the central angle is 150 degrees. Okay, so let's talk about arc length. And for arc length, we have a circle, right? And in that circle, we have what's called a central angle. So the central angle, we're going to call that theta. We have the radius, right, from our angle. The radius goes from the center of the circle to the outer rim. And then we actually have what we have called the arc length, which is S. And the arc length is this piece, right? The piece between our two endpoints of our angle, right? There is a formula, S. So just to put some notations here, S is equal to the arc length, right? And that's meaning that if I were to put a ruler and if I were to measure this arc length, right, the measurement would be S, which is my arc length. R is the radius. And theta is called the central angle but it has one stipulation: it must be in radians. All right, so when you're using this formula, S is equal to R times theta, you want to make sure that theta is in radians. All right, so in this example, we're given the radius, we're given the central angle measure, and we're asked to find this length of arc. All right, so going back to our problem, it says find the length of an arc of a circle whose radius is 14 so my radius is equal to 14. The central angle measure is 150 degrees. Right, but we're going to convert 150 degrees to radians. So now since 150 degrees is within the unit circle, all right, it's also in this function value sheet. 150 degrees is equal to 5 pi over 6 radians. So that's really the most important thing you want to remember when you're calculating the arc length. So here we have S is equal to R times theta. We're going to substitute R for 14. We're going to substitute theta for 5 pi over 6. So S is equal to 14 times 5 pi over 6. So I'm going to just bring the calculator over. All right, so since I'm not using one of the trig functions, sine, cosine, or tangent, I don't have to be particularly concerned with the mode of my calculator. So I'm going to just put this in as 14 times 5 times pi. All right, so I'm using the true value for pi, which is above the caret, divided by 6. And we have 36.65 inches. All right, so that is how you find arc length. All right, now we're asked to find the coordinates of a point on a circle with a radius of 20 corresponding to an angle of pi over 6 radians. And we want to actually find the x and the y coordinates. So we're basically going to use these formulas. X is equal to r times the cosine of theta. And we're going to find the y coordinate by y is equal to the r times the sine of theta. Now later in the course, when we talk about vectors, we're going to revisit these same two formulas. All right, so we have r is equal to 20, and we have theta, which is pi over 6. So in order to find r, we have 20 times the cosine of pi over 6. And in order to find the y coordinate, we have r, which is 20 times the sine of pi over 6. Now, since we're going to evaluate these on the calculator, this is where we need to be careful for the mode of our calculator, because we are using a cosine and a sine function. We're given an angle which is in radian measures, so I want to go into mode. Okay, I want to make sure that I'm in radian mode. Right, so I am in the proper mode. I'm going to go back to the home screen. So the x coordinate is 20 times the cosine of pi over 6. Which is 17.32. And we have 20 times the sine of pi over 6. Which is 10. All right, so we have the coordinates 17.32, 10. All right, in this example, we're given that if the cosecant of t is 2.13 and the cosine of t is 0.88, we're asked to find tangent t rounded to 2 decimal places. All right, so I'm going to bring up the formula sheet just so you can see where I'm pulling these formulas from. Okay, and now there's a couple of formulas for tangent. The tangent can either be 1 divided by the cotangent, or the tangent is the sine divided by the cosine. Okay, I'm going to use this tangent of theta is the sine divided by the cosine. But since our variable is t, I'm going to use t instead of theta. So that's equal to the sine of t divided by the cosine of t, right? And if I look close, I have a cosine, right, which I can substitute in the bottom, but I don't quite have sine, right? So now I'm going to go back to the formula sheet, and I'm going to find out if there's a relationship between cosecant and sine. So remember from our formulas, the sine and the cosecant are reciprocals. All right, so taking a look at this form, we have the cosecant is 1 over the sine of theta. If we take a look at this first formula, the sine is what we want. That's actually equal to 1 divided by the cosecant of theta. So in that formula, I'm going to substitute the sine with 1 divided by the cosecant. Right? And we know the value of the cosecant, so based on that value, we can find the sine. Right? So this is going to equal to 1 divided by the cosecant, which is 2.13, divided by the cosine, which is 0.88. And I'm going to bring the calculator back over. So that's 1 divided by 2.13 divided by 0.88. And we have 0.53. All right, so now we're going to take a look at the 6 trig functions. Now, as far as the formula sheet is concerned, and I'm going to pull that up, we have the formulas for the 6 trig functions, but not as they relate to x, y, and r. This is about the only thing that I really require that you remember in the course, but you don't necessarily have to so much remember it, just know when to use it. So I'm just going to write these over because they're not actually on the formula sheet, but the sine of some angle is y over r. The cosine is x over r. The tangent is y over x. And then we have the reciprocals. The reciprocal of sine is cosecant, so that's r over y. The reciprocal of cosine is secant, so that is r over x. And then the reciprocal of tangent is cotangent, and that's x over y. All right. So notice that we're given the sine value, right, as 12 over 13. I'm just going to jot that here, 12 over 13. We're also given the cosine value is 5 over 13. So we can set these relationships. We can set x is equal to 5. We can set y equal to 12. And we can set r equal to 13. Right? And that's just based on what we were given. So now we can find our other relationships. So if we were asked to find the tangent, right, the tangent is y over x. Our y value is 12. Our x value is 5. For the cotangent, that's just the reciprocal of the tangent, so that's 5 over 12. We have the secant, which is the reciprocal for cosine, so that's 13 over 5. Right, and lastly we have the cosecant, which is the reciprocal of the sine, so that's 13 over 12. All right, so you may want to write those down somewhere. They're not actually on the formula sheet. All right, so now we're given an angle of elevation problem. Right, so it says the angle of elevation of the top of a building is found to be 8 degrees from the ground at a distance of 2 miles from the base of a building. Find the height of the building to the nearest foot. And on these type problems, you want to be careful because notice that it wants the final answer in feet, but it gives us miles. So there's going to be some conversion at the end of this problem. So now if we talk about an angle of elevation, and we're also going to talk about an angle of depression. Okay, for each one of these, we need what's called a horizontal. So for the angle of the elevation, right, we have our horizontal, and that angle of elevation is going up. So if we think about this as a line of sight, okay, here is actually the eye level, all right, which is at the horizontal, and an angle of elevation would actually look up. Okay, your line of sight is always at the horizontal. So this is our angle of elevation. And for the angle of depression, right here again, this is our line of sight. This is the angle of depression. All right, so here we're given an angle of elevation, right? So we're using this first model. All right, so I'm just drawing an imaginary right triangle. All right, so it says an angle of elevation at the top of a building. So this is our building right here. Just put a few windows on it. All right, this is our building. It's found to be 8 degrees. All right, so we had the angle of elevation, which was 8 degrees. And from the ground at a distance of 2 miles. And we're asked to find the height of the building. So we're going to set up a trig function. So the trig function that we're going to set up is a tangent function, right? Because we have our reference angle here, which is given as 8 degrees. We're given the adjacent side, and we want to find the opposite, right? So I'm going to set this up as the tangent of 8 degrees is equal to x or I should say opposite over 2. All right, so at this point, I'm going to give you a second to attempt to finish the problem, and notice that the final answer has to be in foot, and then we're going to return with the solution. All right, so we're going to solve for the opposite side. So I'm going to multiply both sides by 2. Okay, I am going to bring back over the calculator. All right, now since we're using a trig function, we want to make sure that we are in the right mode. Since the angle measure is given in a degree, okay, I want to change the mode of my calculator to degree. And we have 2 times the tangent of 8 degrees, which is 0.281. But keep in mind that this is in miles. Right? Because we were given 2 miles here. And it wants the final answer converted to the nearest foot. Right? So we're going to use what's called a unit fraction, where we're going to convert from miles to feet. So we have 0.281 miles. And then I'm going to set up what's called a unit fraction. We're going to convert from miles to feet. So I'm going to put miles in the denominator and feet in the numerator. 1 mile is equal to 5,280 feet. Right? So this is really just a special form of 1. Right? Because anything over itself is 1. So when you multiply by 1, you don't change your value, but you can change your units. So in this case, when we multiply, the units of miles are going to cancel. So we're going to multiply the 0.281. We're going to multiply that by 5,280. And we have 1,484 feet. Okay. All right, now we're going to take a look at one last problem, and it involves us solving a right triangle. I copied this from XYZ, so sometimes there's some double stamp going on. All right, so it says a right triangle has an opposite angle A, side opposite angle B, and side C as the hypotenuse, which is opposite the right angle. So here again, this is in what we call standard labeling. So I'm just going to sketch that out. All right, so we have angle C, which is the right angle, and the angle opposite that is side length C. We have A is the opposite angle, and the side that's opposite A is side A, and then we have angle B, and the side that's opposite angle B is side B, right? So capital letters for angle measures and lowercase letters are for side lengths, right? So we have that B is equal to 20.5, A is equal to 73 degrees, and we're asked to find side length A and side length C. So here again, we're going to have to set up a trig function. All right, so whenever you set up a trig function, so you want to use Sheaf SOHCAHTOA. Right, so this means that the sine is the opposite over the hypotenuse, the cosine is the adjacent over the hypotenuse, and the tangent is the opposite over the adjacent. So before we label any of our sides, we need to pick a reference angle. We never use C as the reference angle. We're going to use either angle A or angle B. We're going to choose the reference angle depending upon either what we're given or what we're asked to find. Okay, so in this case, I'm going to use A as my reference angle, right? Because I'm given angle A. So that's my reference angle. So now I'm going to label my sides according to the reference angle. So I have 73 degrees angle A. The side that's opposite angle A is side length A, and that's the opposite side. Okay. Then I have side length B, which is the adjacent side. And then we have our hypotenuse, which is across from our right angle. All right, so first we're going to find side A. All right, so we're given the reference angle. I want to find side A, so I have to use my opposite side. When we set up our trig function, there must be only one unknown, right? So I'm going to use B, which is the adjacent. The opposite and the adjacent give me a tangent function. So I'm going to write this out as the tangent of 73 degrees. That's equal to the opposite over the adjacent. I'm going to multiply both sides by 20.5. Since I'm given a degree measure, I want to just reassure myself that I'm in the degree mode. So we have 20.5 times the tangent of 73, which is 67.05. So we have A, which is 67.05. And now we're asked to find C. Now we could set up another trig function, or we could use the Pythagorean theorem. All right, so we're going to find C. So C is equal to the square root of A squared plus B squared. So C is equal to the square root of 67.05 squared plus 20.5 squared. And if I put that into the calculator, so that's the square root of 67.05 squared plus 20.5 5 squared, and we have 70.11.